And here we go.
Hello everyone, it's me Arvind catching you on another Tutor Edu's lecture video. Okay, in this lecture video, I'm going to discuss a new chapter from the Form 4 syllabus, which is the chapter 3 systems of equation. Okay, this chapter is considered to be an easy chapter, but the only thing is it requires you a lot of practice. Okay, so let me discuss the coverage that you're going to go through in the systems of equations. Okay, in this chapter you're going to learn in a total of 2 subtopics, which is the systems of linear equation in 3 variables. Okay, before this you have exposed to 2 variables, which is the x and y, and in this subtopic you will be exposed to a third new variable, which is z. Okay, so totally you will be learning how to solve the linear equations involving x, y and z variables. Okay, it's going to be slightly tricky, but I'm going to show you some of the methodology that you can use to solve the linear equations involving 3 variables. Okay, so move on to this next subtopic, which is the simultaneous equations involving 1 linear equation and 1 non-linear equation. Okay, as we go through, we will be going through this as well. Okay, the only difference between the subtopic 1 and 2, okay, this 1 linear and 1 non-linear equation is only involving 2 variables, which is the x and y. Okay, so these are the overall coverage within the systems of equation. So without further ado, let us discuss the first subtopic, which is the systems of linear equation in 3 variables, which in this case, okay, let me just write in the bracket x, y and z. Okay, so to solve the systems of linear equation in 3 variables, so we can use 2 methods. Okay, method number 1 will be the substitution method. Okay, and the method number 2 is the elimination method. Okay, each method has its own advantage and disadvantages. Okay, for example, the substitution, it will be longer, but it can ensure your working is correct. Okay, elimination method, it's faster, but you must do it carefully. Okay, so that is the difference between the substitution method and elimination method. Usually in examination you are required to use the elimination method, okay, because it saves a lot of time, and number 2, okay, these systems of linear equation in 3 variables can actually be a long question, guys. So make sure save your time in your working. Okay, so what I'm going to do now is, okay, I'm going to show you one example involving the 3 variables, and I'm going to solve that using 2 methods. Okay, the first method I'm going to show you using the substitution method. Okay, and once we are done with the substitution method, okay, and then I'm going to show you the elimination method. Okay, so let me show you the example now. So let's say, okay, you have here 2x plus y plus z equals to 0. Okay, and then 3x plus 2y minus z equals to 7. Okay, and the third equation, 4x plus y minus 5z equals to 22. Okay, so this tree is representing 3 variables. Okay, one thing before solving linear equation in 3 variables, you must check, is there 3 equations available in the question? Okay, if there is 3 equations and 3 variables, then you can proceed to solve. Okay, remember guys, 2 variables, it requires you 2 equations. Since we are involving 3 variables, so you need 3 equations for you to solve. Okay, so 2 variable, 2 equation, 3 variable, 3 equation. Okay, so I hope you get this clear. So from here, let us solve this by using the substitution method. Okay, substitution method. Okay, let me underline this. So what I'm going to do is I'm going to label this as equation number 1, okay, followed by this as equation number 2, okay, and the third one as equation number 3. Okay, so I'm going to teach you how the substitution method works, guys. Okay, so whenever you see 3 variables, okay, the first step what you need to do is you need to make sure that you reduce from 3 variables to 2 variables. Okay, once you get the 2 variables, and then you further reduce into 1 variable. Okay, and using that 1 variable, you're going to substitute that value into the 2 variable equation, and from there you finally get the answer for x, y, and z respectively. Okay, so for substitution method, you can choose any equation you want, okay, and any variable you want to substitute. So for the convenience, it is recommended that you use the you choose variable z as your substitution. Okay, so from here, in this case, I'm going to choose equation number 2. Okay, from equation 2, so from equation 2, so we're going to set our z equation equals to 3x plus 2y minus 7, okay, equals to z is equals to 3x plus 2y minus 7. Okay, so this z, you move it over to the right hand side, and this 7 you move it over to the left hand side. So that's how you get this z equals to 3x plus 2y minus 7. Okay, so this will be your fourth equation. Okay, so since you take it from the equation number 2, so what you do, this equation number 4, so you substitute into the equation number 1 first. Okay, so our motive here is to reduce 3 variables into 2 variables. Okay, that is your first step, guys. Okay, whenever you get 3 variables, make sure your first step is reducing from 3 variables to 2 variables. Okay, so from here substitute. So equation 4 into 1. Okay, so this equation 4 you substitute into equation number 1 over here. So from here, 2x plus y plus z equals to 0. So this is your equation 1. Okay, since your z is now equals to 3x plus 2y minus 7, so you substitute this equation over here. So from here, 2x plus y plus, okay, in a bracket, 3x plus 2y minus 7 equals to 0. Okay, so from here you solve this equation. So 2x plus 3x, so from here you get is 5x. Okay, y plus 2y you get is 3y. Okay, and then this 7, okay, I prefer to move it over to the right hand side. Okay, this is just a small tip I would like to share to you. Okay, whenever you want to form an equation, try to move the number to your right hand side. Okay, it will be easier for you to do the reduction. Okay, so 5x plus 3y equals to 7. So this will be your fifth equation. Okay, so what I'm going to do this, I'm going to box it. Okay, so I'm going to box this. So we have already formed our first 2 variable equation. So remember, guys, we need another equation which involves the 2 variable, then only we can further reduce from 2 variable to 1 variable. Okay, so now our next step is, what we can do is we can now substitute the equation 4 into equation 3. Okay, at first we use the equation 4 substitute into equation 1, and that's how we form this 5x plus 3y equals to 7. Okay, and now what we're going to do is, using this equation 4, we're going to substitute into equation number 3. Okay, I hope you understand my explanation. Okay, So for the next step, what you're going to do is we're going to substitute equation 4 into 3. Okay, so from here, so what is your equation 4? So your equation 4 is 4x plus y minus 5z equals to 22. Okay, since you have your z is equal to 3x plus 2y minus 7, so you substitute this equation over here. So from here, 4x plus y minus 5 in a bracket 3x plus 2y minus 7 equals to 22. Okay, so you perform the expansion. So from here, 4x plus y minus, okay, negative 5 times 3, you get is 15x, negative 5 times with 2y, so from here you get is negative 10y, negative 5 times with negative 7, so from here you get is positive 35 equals to 22. Okay, let us solve this. Okay, start with the variable x. 4x minus 15x, negative 11x, y minus 10y, negative 9y. Okay, so this number, move it over to the right hand side, so it will become negative. So 22 minus 35, so from here you get is negative 13. Okay, so you have all negative here. So what you can do is, so to simplify the equation, so you divide the whole equation by negative 1. So from here you get is 11x plus with 9y equals to 13. So this is your sixth equation. Okay, so what I'm going to do is I'm going to box this equation into red box to differentiate that this equation is involving the two variable. Okay, so I hope by right now you should understand how the substitution works. Okay, basically it's just reduction from 3 variables to 2 variable. Okay, so this equation 4, at first we substitute into equation number 1 and we get a 2 variable equation, and that's how we set as equation number 5. Okay, and then using this equation number 4, we substitute into equation number 3, and we have already come up with the second 2 variable equation, which is the equation number 6. Okay, so basically this is your step number 1, reducing from 3 variables to 2 variables. Okay, so once you get this 2 variable, the rest will be simple, guys. Okay, whatever you learned from the previous form, okay, which is the solving the 2 variable, the step is the same. Okay, only this step is considered to be tricky. Okay, you need to do the substitution one by one, you need to be careful. So once you complete this step, the rest will be okay. So from here, I'm going to show you the second step now. Okay, using this substitution method. Okay, for the step 2, what you do, you reduce from 2 variables into 1 variable. Okay, so what I'm going to do is I'm going to write down the equation here, the equation 5 and 6. So from here, 5x plus with 3y equals to 7. So this is your fifth equation. Okay, and then 11x plus with 9y equals to 13. So this is your sixth equation. Okay, similar concept, we're going to use the substitution method. Okay, this time what we're going to do is we're going to reduce from 2 variable into 1 variable. Okay, so which variable you want to choose, it is up to you, but for the convenience I prefer to choose the y. Okay, which in this case is the equation number 5. Okay, you can choose any variable that you want. You want to choose x also can. You want to choose x which involving the equation 6 also can. It is up to you. Okay, there is no specific method, guys. That is the speciality of this chapter, by the way. Okay, there is no specific method. You can use any variable that you want. Okay, at the end you should get the same answer. Okay, so we're going to choose the equation number 5. From equation 5, okay, so from here 3y is equals to 7 minus 5x. So from here your y will be equals to 7 minus 5x divided with 3. Okay, so this will be your 7th equation. Okay, from here the steps is the standard step. Okay, so using this equation 7, so we're going to substitute into the equation 6. Okay, so from here let us continue. Substitute equation 7 into 6. Okay, so let us continue. So from here 11x plus with 9y equals to 13. So since we know that our y is equal to 7 minus 5x over 3, so what you're going to do this, we're going to substitute this equation over here. Okay, so from here 11x plus with 9 times with 7 minus 5x over 3 close bracket equals to 13. Okay, so from this step, this 3 you simplify, get 1, the 9 you simplify, get is 3. Okay, so the 3 you times in, you perform the expansion. So from here 11x plus with 21 minus with 15x equals to 13. Okay, we are very close to our solution of x variable. Okay, the variable you lift it at the left hand side, the number you move it to the right hand side. Okay, so from here 11x minus 15x negative 4x. So this 21 you move it to the right hand side, so it will become negative 21. So negative 21 plus 13, so from here get is negative 8. Negative 4x equals to negative 8. So from here you get your x is equals to negative 8 divided with negative 4, which in this case your x is 2. So this is your first solution. So let me underline this. Okay, so we have already get our first solution. Okay, now once you get your x value, so it will be very easy to find our y value. Okay, so what you can do actually is, using this x value you can substitute back into the equation 7. Okay, there's no necessary to substitute into equation 5 and 6, but if you choose to substitute over here also can, but for me to save the time I choose to substitute into the equation 7 straight away, because they already give us the equation of y in terms of x, so I can straight away find my y value. So from here y will be equals to 7 minus 5 times with 2 over 3, so I will substitute my 2 over here. So from here when x is equals to 2, so from here y will be equals to 7 minus 5 times with 2 divided with 3. So from here 7 minus 5 times with 2, so from here get is 7 minus 10. 7 minus 10 is negative 3, so negative 3 divided with 3 you get is negative 1. Okay, so this is your second solution. Okay, so this is your second solution, guys. Okay, once you get your x and y value, now it will be very easy for you to find the z value. So how to find the z value? Remember guys, at the early you have already formed in the equation 4, z is equals to 3x plus 2y minus 7. So what you're going to do, we're going to use this equation to find our z value. Okay, when x equals to 2, y equals to negative 1. So from here, okay, you substitute the respective values over in this equation. So z equals to 3 times with 2 plus with 2 times with negative 1 minus 7. So from here you get your z is equals to, okay, let us calculate this together. So 3 times 2 is 6. 6 plus with negative 2 you get is 4. So 4 minus 7 is negative 3. So this is your third solution. Okay, so we have done with the first method, which is the method of substitution. Okay, let me scroll this up. Okay, that is all for the lecture video for today. So in the next lecture video, so I'm going to discuss the second method with the same example, which is the elimination method. Okay, so please stay tuned to the next lecture video. Okay, the first lecture video, which in this case, this lecture video, we have already finished discuss the substitution method. Okay, so I hope you understand the substitution method concept. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming AdMaths lecture videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.